Antonov 225 is the world's largest operational aircraft.
It was the first reusable spacecraft, and it promised to make travel into space affordable.
During the Cold War, the rivalry between East and West was fought not only with missiles and ideology, but with engineering on an almost unimaginable scale. While Western designers focused on efficiency, precision, and cost, Soviet engineers followed a different philosophy: size, redundancy, and survivability at any cost. They built aircraft larger than anything ever flown, submarines designed to outlive nuclear war, and machines so enormous they seemed to defy common sense. To Western engineers, these creations were deeply unsettling, not because they were elegant, but because they worked. This is the story of 12 Soviet machines so massive, so uncompromising, and so strategically disruptive that they forced the West to rethink the limits of modern engineering. Antonov An-225, the largest aircraft ever built. When Western intelligence first saw reconnaissance images of the Antonov An-225 in the mid-1980s, many assumed the photos were distorted. The aircraft looked impossible. Its wingspan stretched wider than a football field, its fuselage rivaled the length of naval destroyers, and its projected weight exceeded anything that had ever flown. But the data confirmed it. The aircraft was real and nearly operational. The An-225 was built to solve a uniquely Soviet problem: transporting the Buran space shuttle and massive rocket components across the vast Soviet Union. Rail lines were too small, sea routes were slow and vulnerable, so instead of redesigning the space program, Soviet leadership ordered engineers to build an aircraft large enough to ignore logistical limits altogether. Powered by 6 massive turbofan engines, the An-225 had a maximum takeoff weight of over 640 metric tons. Its 32-wheel landing gear spread the load across reinforced runways, while its strengthened cargo floor could carry payloads heavier than most Western aircraft could transport in total. Western engineers were shaken by its capabilities. It could carry more than 250 metric tons, nearly double the payload of the American C-5 Galaxy. Suddenly, the Soviet Union could move oversized military equipment or space hardware anywhere without relying on ports or rail corridors. Even more surprising was its flight behavior. Despite its size, the aircraft handled smoothly at low speeds and demonstrated stable takeoffs. It wasn't just oversized, it was carefully engineered to operate at the edge of physical possibility. Its first flight in 1988 proved it. Though only one was built, the An-225 permanently changed perceptions of Soviet industrial capability. Typhoon-class submarine, the Doomsday Leviathan. Few Soviet weapons disturbed Western naval engineers more than the Typhoon-class submarine. Hidden beneath Arctic ice, these vessels were not built to win battles. They were built to survive the end of the world. Developed in the late 1970s, the Typhoon carried the R-39 ballistic missile, the largest submarine-launched missile ever deployed. Instead of shrinking the weapon, Soviet engineers redesigned the submarine around it, creating a multi-hull structure inside a massive outer casing. At over 175 meters long and nearly 48,000 tons submerged, the Typhoon was the largest submarine ever built, far larger than America's Ohio-class boats. Western doctrine emphasized compact, quiet designs. The Typhoon seemed too large to be stealthy, but Soviet engineers isolated machinery on vibration mounts and built thick hulls to absorb sound. In Arctic waters, sonar operators often mistook them for shifting ice. The submarines were built for polar operations, able to surface through thick ice and launch missiles from regions where Western forces had little access. Nuclear reactors gave them months of endurance underwater. Inside, they even included saunas and gyms, not luxuries, but tools to keep crews effective during long-deterrence patrols. What truly alarmed Western planners was redundancy. Multiple reactors, duplicate systems, and compartmentalized hulls meant a Typhoon could survive damage that would destroy other submarines. Strategic simulations showed that some would always survive and retaliate. Buran Space Shuttle, the shuttle that flew itself. When the Soviet Buran shuttle appeared in the late 1980s, many Western engineers assumed it was just a copy of NASA's space shuttle. That illusion vanished once its technology became known. Unlike the American shuttle, Buran launched atop the Energia rocket, But its most unsettling feature was automation. The shuttle could fly an entire mission without a crew. In November 1988, it did exactly that. Buran orbited Earth twice, then landed autonomously on a runway in Kazakhstan without human intervention. At the time, NASA's shuttle required astronauts to control re-entry and landing. The idea that a spacecraft of Buran's size could land itself challenged Western assumptions about automated flight. Weighing over 105 tons, Buran carried thousands of heat-resistant tiles and a large payload bay. Its engines were mounted on the rocket, not the orbiter, reducing structural stress and increasing safety margins. Though the program ended with the collapse of the Soviet Union, Buran proved something unsettling. Soviet engineers could match, and sometimes surpass, Western space technology. Ekranoplan, the Caspian Sea monster. In the 1960s, American satellites spotted something enormous skimming the Caspian Sea. It was too large to be a plane, too fast to be a ship. NATO called it the Caspian Sea monster. It was an ekranoplan, a ground effect vehicle that flew just meters above the water. By riding a cushion of compressed air, it combined the speed of an aircraft with the payload of a ship. The prototype stretched over 90 meters and weighed more than 500 tons. It could fly at over 400 kilometers per hour, below radar coverage designed for conventional aircraft. Later versions, like the Lund class, carried heavy anti-ship missiles. They were effectively high-speed strike platforms that could appear with little warning. To Western planners, it was a nightmare, a missile-armed vehicle approaching at aircraft speeds, but invisible to many radar systems. MAZ-7907, the mobile nuclear launcher. The MAZ-7907 wasn't a weapon. It was the machine that carried the weapon, and that made it terrifying. Designed to transport massive intercontinental ballistic missiles, the 28-meter-long vehicle weighed over 65 tons without its payload. With a missile on board, its mass pushed engineering limits. It rode on 24 wheels, each independently driven and steerable. A gas turbine engine powered an electric transmission system, distributing power to all wheels and giving it surprising mobility across rough terrain. It could disappear into forests or tundra, hiding missiles where satellites couldn't easily find them. Western strategy depended on targeting fixed silos. Mobile launchers shattered that assumption. Object 279, the nuclear-proof supertank. Object 279 looked almost alien. Built in the late 1950s, it had 4 tracks arranged in 2 pairs, reducing ground pressure so it could cross mud, snow, and nuclear-blasted terrain. Its elliptical hull was designed to deflect shock waves from atomic explosions. Soviet engineers believed the shape could prevent the tank from being flipped by a nearby nuclear blast. Weighing around 60 tons, it carried a powerful 130mm cannon and a sealed, filtered crew compartment for operating in radioactive environments. To Western engineers, the implication was chilling. The Soviets expected tank battles to continue after nuclear strikes. Only one prototype was built, but its philosophy was clear: designed for nuclear war, not conventional conflict. Tsar tank, the giant that failed. Long before the Cold War, Russian engineers experimented with extreme size. The most famous example was the Tsar tank of World War I. It featured 2 enormous front wheels, nearly 9 meters tall, and a smaller rear wheel. The idea was simple: roll over trenches and obstacles instead of navigating them. A scale model impressed Tsar Nicholas II, and construction was approved, but the full-size machine revealed fatal flaws. The rear wheel sank into soft ground, and the engine lacked the power to free it. During its first test in 1915, the giant tank advanced only a short distance before becoming stuck forever. It was abandoned and left to rust in the forest. Yet, it revealed an early Russian willingness to pursue scale at the expense of practicality. T-35, the multi-turret fortress. When the T-35 rolled through military parades in the 1930s, Western observers were stunned. It looked like a moving fortress. The tank had 5 turrets, a central cannon, and 4 smaller weapon turrets. In theory, it could engage multiple targets at once. In practice, the design was incredibly complex. It required a crew of up to 11 men, and coordinating fire inside the tank was extremely difficult. Weighing over 45 tons and nearly 10 meters long, it was impossible to conceal. Its size made it an easy target for artillery. mechanical reliability was its greatest weakness. Many were lost not to enemy fire, but to breakdowns. Still, the T-35 served as a symbol of Soviet industrial power, a terrifying image, even if its battlefield performance was limited. Ural 375 and Maz haulers, trucks of strategic mobility. For the Soviet Union, logistics was a weapon. Vast distances and poor infrastructure demanded vehicles that could move anything, anywhere. The Ural 375 was a rugged 6x6 truck built to operate without roads. It hauled artillery, missiles, troops, and radar systems across mud, snow, and forests. It consumed fuel at alarming rates, but it was easy to repair in the field. Soviet planners valued reliability over efficiency. MAZ heavy haulers operated on an even larger scale. With multiple axles and enormous tires, they transported missile systems and equipment weighing tens of tons. Some stretched over 20 meters long. They could move intercontinental missiles away from fixed sites, making them harder to target. To Western engineers, the message was clear. Soviet weapons were mobile, unpredictable, and difficult to neutralize. Duga radar, the Russian woodpecker. In the 1970s, radio operators across the world heard a strange tapping sound interfering with communications. It became known as the Russian woodpecker. The source was Duga, an enormous over-the-horizon radar designed to detect incoming missiles. Its antenna arrays stretched hundreds of meters across and towered over 150 meters high. The structure resembled a steel city. Duga transmitted powerful signals across global radio frequencies, disrupting communications worldwide. Western analysts realized the Soviets were willing to jam civilian systems to protect their nuclear deterrent. The radar was expensive, power-hungry, and often unreliable, but it demonstrated a willingness to build at colossal scale for strategic advantage. K-7 Flying Fortress, the aircraft ahead of its time. In the early 1930s, Soviet engineers unveiled the Kalinin K-7, a flying fortress decades ahead of its time. It had a wingspan over 53 meters and weighed more than 40 tons. Its thick wing housed crew compartments, fuel tanks, and internal systems. 7 engines powered the aircraft. It was designed as a bomber, transport, or airborne command center. But structural vibrations plagued the design. In 1933, a catastrophic crash ended the program. Even so, many of its concepts, large wings, heavy payloads, internal crew spaces, would appear decades later in strategic bombers. Baikal-Amur mainline machines, giants that carved Siberia. The Baikal-Amur mainline stretched over 4,000 kilometers across Siberia, through permafrost, mountains, and seismic zones. Western engineers believed such a project would take decades and require massive foreign support. The Soviets chose a different approach: build machines so large and rugged that the environment became secondary. Massive bulldozers, excavators, and track-laying machines operated in temperatures below -40 degrees Celsius. Reinforced frames and simplified systems allowed continuous operation where conventional equipment would fail. Tunnel boring machines were built to survive rock collapses and seismic shocks. Breakdowns were expected, not feared. The railway was not just economic. It provided a strategic logistics route deep inside Soviet territory. To Western engineers, the message was clear. With enough scale and endurance, even Siberia could be conquered. Across air, land, sea, and even frozen tundra, Soviet engineers built machines that defied logic and redefined scale. Some failed, others became legends, but all delivered the same message. In the Cold War, sheer size wasn't excess. It was strategy, and sometimes survival itself.